All right, we're on to the next one, which is the file system check progress discussion. So, jump right in.
Okay. Yeah. So John's been going gangbusters, writing a bunch of sort of examination and repair tools for if you lose your entire metadata pool and want to repair it from what's in the data pool, or if you lose all your journals and want to repair it from what's on the directory fragments or whatever. And I need to push the latest version, it's becoming mythical at this point. But there is an in-progress forward scrub that goes through from the root inode and scrubs forward to everything and validates it. And I just thought we'd give an update on. And honestly, there's just sort of like, yep, that one's still going. But I thought we'd give an update on where the repair stuff is and talk a bit about how we want to go into integrating them now that we have more code written down than the last time we discussed this a year or so ago. And I've been talking for a long time, so John, do you want to talk a bit about what the repair tools look like in their current state?
Sure. So the new tool is called CephFS Data Scan, so named because it scans across the objects in a data pool. And it's basically a two-phase thing, where the initial phase is to go and look at every object in the data pool and identify from the name which inode it refers to, because data objects are named inode.offset, and decorate the 0th object in the inode with some new extended attributes for the maximum size of an object seen, the highest offset of an object seen, and the highest M time seen. So that's essentially recalculating all the metadata we can for every inode and storing it on the first object, or the 0th object, as I keep calling it, on each inode. And then the second stage is to iterate over these 0th objects, so one per inode, and for each one of them, read this recovered metadata, read the backtrace if one is present, and use that information to attempt to inject linkage for the inode into the metadata tree. So if it already sees a dentry in the metadata pool, it will go, okay, great, and move on. And if it doesn't, it will go ahead and create a dentry for the inode, and also for any parents that are necessary for the directory that it's injecting into. All of that is a best effort thing, because it's not guaranteed that a backtrace will be there. So there is also a lost and found directory where inodes go if there's no backtrace. And it doesn't currently guarantee that what you end up with in the metadata pool is actually itself completely consistent. So if it sees an existing dentry for something in a directory fragment, it doesn't guarantee that that directory fragment is itself linked into the metadata tree. So there's still work outstanding to do the metadata equivalent of the process that we're currently doing for data recovery. The scale and performance of this is kind of important, because if you've got many millions of data objects and you want to do some recovery on your file system, you will wait months for that to execute. So there is this new thing called sharded PGLS, where when we enumerate objects, we can pass multiple worker processes a subspace of the objects in a given pool, and that it hasn't made it into Rados yet. But when it does, this tool is designed to work with that. So you would create a number of worker processes for CephFS data scan running on different clients, and they would all take a share of the data objects and do their thing on those. And that kind of already works because it did work with the previous incarnation of sharded PGLS, but currently that's not wired up because we're waiting for waiting for Rados to get that functionality again. So that's the new tool, and there are a bunch of tickets for adding extra cases to that we've recognized but not written the code for yet. So the one I already mentioned was doing the equivalent process for dirfrag objects that we already know how to do for data objects. And the other B in that list is detecting snapshots. So currently when the tool sees a snapshot, well, it doesn't do anything because it doesn't see a snapshot. It just looks at the latest version of all the objects. And if you had any snapshots and you inject the linkage for those inodes, the snapshotted data will continue to exist and take up space in Rados, but it will never actually have been linked in to the CephFS metadata tree. So the initial simplest way of handling that will be to find the snapshots during the scanning phase that we do, and then report them to the user and possibly offer a way to purge them. And then the slightly more advanced thing is actually to try and hook them into CephFS snapshots that already do exist in the metadata tree. So that's the recovery tool. The related part is adding something called the damage table to the MDS. So in order for the user to know that they need to run this type of tool, the system needs to have found the damage to begin with. And the main mechanism for that is the forward scrub. But it's not just the forward scrub, it's also every time we load something into cache on the MDS, we can potentially detect that something's been broken. So we need somewhere to put the information about what's broken so that we can disable broken subtrees and not keep trying to load them. So currently there are a bunch of places where the MDS rank gets marked damaged, which causes the daemon to shut down and no other daemon to take a rank when it hits one of these errors. And that's kind of a bit heavy-handed because you might, have only lost one directory in your whole system, and we'd much rather give you EIOs on that directory rather than shutting down the whole thing. So that code is less far along, but it's kind of related to this whole picture. Greg, anything to add?
No, I think that's about where things are right now. So let's talk about some of those. The dirfrag process is, I think, just going to look like what you've done with the inodes, but for the metadata pool, or
yeah, it's the same thing. The difference is that obviously with dirfrags you don't have to do the whole initial scanning to work out the extents of things. The thing you do have to do is find all the dirfrags that refer to a particular inode and work out if they form a consistent frag tree, and regenerate. If we've lost the parent inode for the directory, then we don't have the frag tree, and we have to go and work out what it is. So it's all very similar, but it's there is that new piece as well of handling the frag trees.
Makes sense. Let's see. And the other thing I want to talk about was, all right, so once forward scrub and everything is done, then we're going to have this thing where we can mark that we know that mark inodes as we know as being linked into the tree appropriately. And we'll want to be able to filter those out when trying to do this repair process, right?
Right. So we'll want to filter that ideally on the OSD side inside the PGLS, so that we're only looking at inodes that are really, worthy of our interest, which might add an extra step to the process because at the point where we're iterating over all the objects in the pool, not just the header objects, those won't have all been marked by forward scrub. presumably, because that would be crazy to have it do that. So it might be that we have to do the initial pass to find any 0 objects that are eligible for recovery, and then pass that list of inodes back into the procedure for scanning to find metadata for them, and then come back again and do the injection. The problem with that is it means that if there were any missing header objects for anything, and stray data objects, we still wouldn't find them. So you'd still, in order to do the procedure exhaustively, you would still need to do the scan over every single object in the pool. The thing that the tagging saves you from is trying to do unnecessary injections of the metadata that you've recovered.
Right. And actually, even for the stuff that has been tagged, you might want to go through and do the file size recovery stuff, because it could have been like accessed and have an unknown file size, but still be linked to the tree consistently. But what I'm thinking about in particular is that, assuming we do find actual head objects that are unlinked, we might, like, if we only lose one link, like between one directory and its parent somehow, or like we lose one dir frag, and so there's sort of a one level gap in directory tree between the grandfather and the entire ancestors. Then trying to go through and do linkage for everything that didn't get tagged might be the wrong approach. We might want to, or we probably do want to, when we find something that hasn't been tagged, we probably want to try and scan from it up and down the tree, if that makes sense. Like, we find file foo that wasn't tagged. Here's its backtrace. Let's see how far back up its backtrace we can find that it finds stuff connected. And then, okay, we got to an ancestor, and that ancestor isn't connected to the tree, but let's try scanning forward from that ancestor.
So, when we're in the offline world and we want to scan forward, it's kind of doable. If you'd identified a particular dir frag, was a particular directory inode that wasn't linked into the metadata tree, and that was your sort of slice point, what would you do? You'd find all of its fragments, and you would potentially decide that you were happy with everything that was. You'd need a second stage for going and marking everything beneath it, right? So you'd need a stage for finding all the fragments in that directory, and then you'd need to recurse down them and tag everything down them to say this is like semi-linked in that it's linked into something, just not the root. And then you would go back and do your general purpose repair, except you'd be respecting both kinds of tags, so you'd only actually end up injecting linkage for the point at which the break had occurred.
Yeah, do we actually want to tag and consider the tagging as being separate for whether it was linked to the root versus linked to something? Would that actually be a useful distinction?
I mean, I think the reason I was sort of intuitively inserting that was that one of them is coming from an online MDS, and one of them is coming from the offline tool. But at the point that you're actually respecting the flags and doing the recovery, I don't think you treat them any differently. So maybe they're not meaningfully different.
Yeah. Anyway, so I'm just trying to think about how we'd go about coordinating those. And also, I'm not sure we want to have separate sort of tagging mechanisms. I think we might just want to have like a limited sort of MDS running that can do this, if that makes sense.
Do which part?
Like we ought to be able to do the tagging. Like I think we should be able to just like have one running and forcibly inject a de-entry location into it and be like, use this as your root and run forward scrub.
Oh, right.
And it would be in a mode that wouldn't allow it to do anything except write the tags, but
yeah, I mean that would be it's less. I mean, it's less that we actually want an MDS and more that we would like the code that does that process to be usable outside of an MDS.
Yeah, and I've been trying to do that. Although I mean, it's using inodes, so but also like we get all the other checking involved that they do without having to duplicate it in terms of
no, it would be a good thing not to duplicate that. It might be that it might be the case that code needs an MD cache perhaps, but doesn't need everything else. So maybe we could deliberately spin up a sort of micro MDS that doesn't have a session map or an MD log or any of those things.
Yeah, I mean,
it makes me a little bit queasy
right now, but I'd like us to be able to decompose things that way.
I'm sorry, I missed that last.
Each other. I was saying I don't think you can have an MD cache without all the other things right now, but I would like us to be able to decompose the classes and the memory structures that way.
Right. So right now, if we wanted a baby MDS, we would be relying on sort of strategically placed if statements to make sure that it wasn't going rogue and doing things it shouldn't. And I'd much rather be relying on the objects not having been constructed to begin with. But there'll be, as you say, there'll be a change. It's not something we can do with the current code.
Okay. So let's see. So we write the metadata dirfrag scanner. We write the inject a root. So would this mean that like once you start up the backwards thing, then we would go until we find a root, or not a root, but a disconnected thing, and then pause? Do you think? I'm not sure. Like logically speaking, I think that's what we want to do is like find something, or like find something from a disconnected tree and then scan it, and then look again for things from disconnected trees. And if we find them, scan it, and hopefully we don't because we just lost one object or something.
So
I'm not sure, and also I'm not sure how we want to do that communication. Like, do we want a big table of detected lost inodes? Or
we'd implicitly find disconnected pieces of metadata during the scan of the data pool. So if we're going up these back traces, and at some point, we could make it only inject the first level of parent, perhaps, and that way, if you then came and scanned the metadata pool, you would find, here's a disconnected guy, and here's a disconnected guy, and here's a disconnected guy. And when we're scanning the metadata pool, the definition of disconnected would just be, is the immediate parent absent? And so that would then, during that scan of the metadata pool, we would get a hopefully much shorter list of parentless dirfrags.
Yeah.
And then that would be the input to the go tag the children of this tree process.
Yeah, so we just have the immediately parentless dirfrags, and then also probably all of the file inodes that didn't get tagged already.
Why do you want file inodes to come up in this?
Well, I mean, because we'll lose a directory that's at the bottom or whatever. Like we'll lose a directory and none of its files will get touched, and we need
to. What I'm saying is that if you run the metadata recovery first, that knows how to do entry injection, and just tell it only inject one level of parent.
Oh, I see.
Then all the files would have linkage, but the directories potentially wouldn't. I'm looking for ways that avoid ever having a big list OI nodes, because in the case of like losing your whole metadata pool, that list is the list of every inode in the system.
Yeah. So my concern with that, it'd be nice if we didn't have to go through a bunch of passes. But my concern with just directly injecting the inodes is that, like, if the backtrace is stale, but it's linked in somewhere else, we need to resolve that.
Okay, so all right, so you're talking about the case when there's a splice in the metadata tree such that forward scrub wasn't able to mark a directory, wasn't able to mark a file as having linkage, and then we go and inject new stale linkage for the file because it wasn't tagged, and that way we end up with double linkage for a file.
Yeah.
My instinct is that we will handle that in a subsequent phase for finding double linkage of files.
Yeah.
Because the alternative, or rather than having a table of inodes as such, when we inject, well, so actually it's kind of equivalent, because if we were going to create a table of the inodes that should be in every directory, it would just look like a dirfrag, right? It would be a dirfrag with a different name. So maybe we should inject the linkage for the inodes to a dirfrag, but rely on these flags indicating that it's a not fully trustworthy one, to inform the subsequent phase that goes and cleans this mess up once things are linked back in.
Yeah.
Because for me, the phase that does like a single level of inject some linkage should be separate from anything that does a sort of large number of inodes type of operation, rather than bringing that whole list of inodes into the process of actually injecting linkage.
Yeah.
The good news is we have all day on Tuesday and Wednesday to discuss this.
Yeah. Okay, we still got 7 minutes left. Okay, so I guess what we would do then is that when we're doing the tagging, if we had, like, we would want to set it up so that the tagging would inform us and it would fail if there was already a tag set, and then we could create a list of double linked files from that. That would
right, and that code needs to exist anyway, right? Because that's one of the what Scrub already needs to do. So it would be a case of making sure that side of things happened again after we'd done any metadata linkage, and then finally making sure that once we detected double linkage of files, we had a way to fix it.
Yeah. And I mean, and if we were like marking everything that was injected as an injected link and less trustworthy than others, then, we could tell that. We'd just be like, hey, yes, you were injected, you're bad. Or if they were both injected, we'd have to go check the versions, but we could do that. Okay.
Mm-hmm.
Yeah. That makes me happy. Okay. I was thinking of something where like we go through and scan for unlinked stuff and then pause the scan while we do a scrub once we find something and then start the scan again. But that seems really inefficient. Okay. This is much better. Good. Okay. That all makes sense. I feel good. Let's see. Were there any of your tickets that we didn't talk about that you want to?
No, there's like 15 of them, but mostly they're too detailed to go over here.
Okay. We've got 5 minutes left. We can talk really lightly about snapshot handling, or we can give up the floor and keep running early.
Well, I've got a train to catch, so I wouldn't mind a few minutes early.
All right. I think we're done then, Patrick.
Anyone else have any other questions? I'm not hearing anything, but give it a minute.
Need more people to go find some starter tasks and do them, and then they'll talk to us next time about these.
Right.